Hello and welcome to the solution video to my 2024 Edexcel Practice Paper 2. Before watching this video, I'd encourage you to read the disclaimer that's on the front of the paper. I've put a lot of effort into analysing the past papers and of course what topics already came up in paper 1, but this offers no guarantees at all. There are many topics that I couldn't fit into this paper that may well appear, so I'd remind you to revise all topics as technically anything could still be asked. It is definitely best to try the paper before watching this video. You can find a link to the paper in this video's description. In this question, we're asked to expand and simplify. We're going to do the expanding part first. So if we look at the first bracket, we need to do 10 multiplied by n, which is 10n, and then 10 multiplied by 6, which is plus 60. Then onto the second bracket, it's negative 2 times n, which is negative 2n, and then really importantly, negative 2 times negative 5. When you multiply two negatives together, you get a positive, so we actually want to write down plus 10. It's very common for students to make a mistake and put negative 10 here. Now we need to do the simplifying part. We can collect together the like terms. We've got 10n subtract 2n. 10n subtract 2n is 8n, and then we've also got 60 plus 10, and 60 plus 10 is 70. So it's 8n plus 70. In this question, we need to convert 8.1 times 10 to the power negative 3 into an ordinary number. To do this, we're going to start with 8.1, and because it's a negative power of 10, we're going to divide it by 10 3 times. If we divide it by 10 once, we get 0.81, a second time 0.081, and a third time 0.0081. So the answer is 0.0081. For part B of the question, we need to write 419,000 in standard form. For a number in standard form, the first part must be between 1 and 10, so we're going to use the number 4.19. Then we multiply this by a power of 10. So we just need to work out how many times we would need to multiply 4.19 by 10 to get 419,000. To do this, I'm going to place the decimal point into the number as though it reads 4.19. Then if we multiply it by 10 once, we get 41.9, twice would be 419, a third time, a fourth time, and a fifth time. So to get to 419,000, I multiplied it by 10 5 times, so it's 10 to the power 5. For part C of this question, we need to do a calculation in standard form. But since this is paper 2, you can just type that exactly as it is into your calculator. If you do that and then press equals, you'll end up with this number here. This question says to give your answer to 3 significant figures though, so we can lose most of these digits. We just want the 6, 6, and the 4. Then we need to write this number in standard form. So as before, the first part needs to be a number between 1 and 10, so we'll need to use 6.64. Then we multiply this by a power of 10. Now this time, this number is quite a small number, so we would actually divide 6.64 by 10 a number of times. If you divided 6.64 by 10 once, it would be 0.664, and if you did it a second time, we'd get 0.0664. So we divide it twice, so it's 10 to the power negative 2. If you find any of question 2 tricky, I have a video dedicated to standard form. I will link that in this video's description. For the first part of this question, we need to find the class interval that contains the median. The first thing we need to know for this is the total frequency. We can get that by adding up the frequency column here. If you add up all of these numbers, you get 100. So there are 100 cars represented in this table. The median is the middle number when the numbers are in order. So if there are 100 cars, we can add 1 to 100 to get 101, and then divide this by 2 to get 50.5. This tells us that the car that's in the middle is the 50.5th one. Now that might sound weird because you can't have a 50.5th car, but we're still going to use that as though it's true in this question. To find the 50.5th car, we count down this column here until we hit 50.5. In the first group, for the cars with a speed between 30 and 40, there's only one car, so we're nowhere near the 50.5th car yet. Then if we include the second group as well, we've got 14 more cars, so 1 plus 14 is 15. We're still quite far away from 50.5. If we include the next group, however, we add 37 more cars in, so 15 plus 37 is 52. So we've now gone past the 50.5th car, so we can be sure that it's in this group. We need to write the answer as the class interval, and that was cars with speeds between 50 and 60. So that's exactly what we write down. 50 is less than s is less than or equal to 60. For the second part of the question, we need to work out an estimate for the mean speed of the cars. To do this, we're going to need to use the midpoints. For the first group, the speeds are between 30 and 40, The midpoint of 30 and 40 is 35. In the next group, it's from 40 to 50, and the midpoint is 45. And the midpoints for the next two groups are 55 and 65. We then multiply the midpoints by the frequencies, so 35 times 1, which is 35, 45 times 14, which is 630, 55 times 37, which is 2035, and 65 times 48, which is 3210. If we then add up this final column, we get a total of 5820. This represents an estimate for the total speeds of all of the cars. To find the mean, we then need to divide this by the number of cars. Well, we actually know the total number of cars because we worked it out in part A. It was 100 cars. So we just do 5820 divided by 100, which gives you 58.2. So the answer to this question is 58.2. If you found any of this question tricky, it's on averages from tables or diagrams. I once again have a video that I'll link in this video's description. For part A of this question, we need to complete a table of values. You can see we have all of the x values, but we need to work out the y values. We're going to do that by substituting the x values into this expression here. So x squared plus 2x minus 5. We'll start with when x equals negative 4. So we're just going to copy that out again, but replace the x's with negative 4. So instead of x squared, it's negative 4 squared. Instead of 2x, it's 2 lots of negative 4, and then subtract 5. You can just type this straight into your calculator, and it will give you the answer 3. So when x equals negative 4, y is equal to 3. Now they've already done negative 3 for us, so we'll move on to negative 2. So we copy out x squared plus 2x minus 5 again, but replace the x's with negative 2's. So instead of x squared, it's negative 2 squared. Then plus 2x becomes plus 2 lots of negative 2, and then subtract 5. If you type this into your calculator, you get negative 5. So if x is negative 2, y is negative 5. Then we do the same thing for 0, so it's 0 squared plus 2 lots of 0, subtract 5, which is negative 5 as well. So when x is 0, y is negative 5. In part B of the question, we need to draw the graph. To do this, we're going to take each pair of x and y values and plot them as coordinates. So the first pair is when x is negative 4 and y is 3. This is the coordinate negative 4, 3, which goes here. The next one is negative 3, negative 2, which goes here. Then we have negative 2, negative 5, negative 1, negative 6, 0, negative 5, 1, negative 2, and 2, 3. So you end up with these points here. You now want to join these with a nice smooth curve, something that looks like this. In part C of the question, we're asked to estimate the roots of this equation. Notice how this equation matches the same equation as the graph that we drew. So to find the roots of this equation, we're just looking for where this graph crosses the x-axis. You can see it crosses the x-axis in two places, here and here. So we just need to write down the values of these. The one on the left is x equals negative 3.5, and the one on the right is x equals positive 1.4. Now your answers might be slightly different to this based on how you drew your graph, but as long as you're near to these, you'll probably be fine in the exam. In this question, we need to write down an error interval for 1.79 that's been rounded to 2 decimal places. To do this, I like to draw out a number line. I place the number from the question in the middle, so 1.79, and then we want to write down the number that's immediately below this and immediately above this to 2 decimal places, so that'll be 1.78 and 1.80. The error interval is then formed by this section of the line here. So we want to find the number that's halfway in between 1.78 and 1.79, and that's 1.785. And also the number in between 1.79 and 1.8, and that's 1.795. These two numbers form your error interval, so it's 1.785 for the lower one and 1.795 for the upper one. Once again, I have a video on this topic if you find this tricky. There's a link to that in this video's description. In this question, we've been told the number of blue counters to the number of green counters is in the ratio 2 to 5, and we've been asked to complete this table. Well, we do already have some of the probabilities for red and yellow, 0.4 and 0.04. If we add those together, we get 0.44. Now the probabilities for all of the colours must add together to give 1. So if we do 1 subtract 0.44, we get 0.56. This means blue and green must add together to give 0.56. Now we can return to this ratio. The ratio of the number of blue to the number of green is 2 to 5. So that will also be the ratio of their probabilities. So if we write down blue to green is in the ratio 2 to 5, and then we create this table with a total column. If we add up 2 and 5, we get 7. 7 parts must represent all of the probability, which we said was 0.56. Now we need to work out what we could multiply 7 by to get 0.56. Now you can do this by doing 0.56 divided by 7 on your calculator, which is 0.08. This just means we can multiply the 2 and the 5 by 0.08 as well to work out their probabilities. 2 times 0.08 is 0.16, and 5 times 0.08 is 0.4. So the probability for blue is 0.16, and the probability for green is 0.4. In this question, we have ABCDE, which is a pentagon, and we need to work out the size of angle DEA. Since this is a pentagon, we can work out the sum of its interior angles using this formula here, where n is the number of sides. Since a pentagon has 5 sides, we can replace n with 5, so it's 5, take away 2, times 180, which is 540. This means all of the angles in a pentagon must add up to give 540 degrees. We already know the size of 2 of the angles, the 100 and the 76 here. So we can subtract those from the 540. 540, take 76 and take 100, is 364. So the remaining 3 angles must add up to 364. Now we're told something about those 3 angles, we're told their ratio, it's 6 to 5 to 2. So if we write out this ratio of BCD, CDE and DEA, and create a total column, the ratio was 6 to 5 to 2, and the total number of parts there is 6 plus 5 plus 2, which is 13. So 13 parts must represent all of the angles, which we said added up to 364 degrees. So we just need to work out what you would multiply 13 by to get 364. So do 364 divided by 13, and you get 28. So we can just multiply the other parts of the ratio by 28 to find out their size. 6 lots of 28 is 168, 5 lots of 28 is 140, and 2 lots of 28 is 56. Now in the question we were asked for angle DEA, which we've now shown is 56 degrees. So the answer is 56. We're going to start this question by looking at the triangle on the left. This triangle is a right angle triangle, so we can use SOHCAHTOA. So if we label the longest side, opposite the right angle as the hypotenuse, the one opposite the 62 as the opposite, and the remaining side is the adjacent. Now in this question it's really helpful to work out the value of the opposite, because that side is also on the triangle on the right hand side. So we're going to try and find the opposite. To do this, we'll need the opposite and the other information we're given in the question, which is the hypotenuse, so O and H, which means we need to use sine. So you can write down that sine of 62 is equal to the opposite, which we don't know, so we'll just call that O, over the hypotenuse, which is 19. If you now multiply both sides by 19, you find that the opposite is 19 times sine 62. If you type this into your calculator, you'll get the opposite as 16.776 and so on. So let's replace this side, which we called the opposite, with 16.776 and so on. Now if we look at the triangle on the right hand side, we're trying to find the angle x. We can once again use trigonometry. So if we label this triangle, the hypotenuse is the longer side opposite the right angle here, the opposite is the one opposite the angle x, which is this one, and the adjacent is the one at the bottom down here. This time we know the opposite and the adjacent, so we want to use tan. So we could write down that tan of the angle, the thing we're trying to find, is equal to the opposite, which was 16.776 and so on, divided by the adjacent, which is 15. Then we just use the inverse tan function, so x will be equal to inverse tan of this, and if you type that into your calculator, you'll get this number here. The question says to give your answer correct to 1 decimal place, so if we round this, it's 48.2. It's really important that you use the full number for the 16.776 and so on. Don't round that number off earlier in the question, else you'll end up with a different answer to the one I got. This is another topic that I have a video dedicated to, you'll find a link to that in this video's description. In this question we have D who invests £3,200 in Bank A, and we can see that Bank A has compound interest at 1.5% each year. So we can just use the formula for compound interest. So D's money, which is 3,200, then we multiply this by the multiplier for a 1.5% increase, which is 1.015. Then we need to do this for as many times as the number of years that she invests it for, and in the question we can see it says after 5 years, so we do this to the power 5. If you type this into your calculator, you'll get this number here. Now we need to do the same idea for Justin. Justin invests £3,000 in Bank B, but the interest rate's a little bit more complicated for this one. is 4.5% for the first year and then 3.5% for each extra year. So he will invest £3,000, and in the first year he'll gain 4.5% interest. So let's multiply this by the multiplier for a 4.5% increase, which is 1.045. But we only do this for 1 year. In all of the remaining years, it's 3.5% interest, so a multiplier of 1.035. But since we're doing it for 5 years in total, and for the first year it was 4.5%, the 3.5% will be applied 4 times for the remaining 4 years. So we do that to the power 4. If you type this into your calculator, you'll get this number here. The question says how much more money will be in Justin's account compared to D, so we need to subtract these and find the difference. If you subtract these, you'll end up with this answer here, £150 and 17 pence. Now it is possible that you may get an answer 1 pence different to this if you type the whole thing in one calculation. That will also be absolutely fine. In the first part of this question, we have a bracket raised to the power 1/3. A power 1/3 means to do the cube root. So we need to do the cube root of 27g to the 9 h to the 12. We'll start by doing the cube root of 27. Now you might already know this, or you could use your calculator to work it out, but the answer is 3. Then we need to do the cube root of g to the power 9. We can do this by multiplying 9 and 1/3, and 1/3 of 9 is 3. So it's g to the power 3. Another way to think about this is what power of g would you need to multiply by itself 3 times to get g to the power 9? And it's g to the 3 times g to the 3 times g to the 3 gives g to the 9, since you add those powers together. In a similar way, for h to the power 12, we can do 1/3 of 12, which is 4, so h to the power 4. And this works because h to the 4 times by h to the 4 times by h to the 4 gives you h to the 12, since 4 add 4 add 4 is 12. So the answer to the question is 3, g to the power 3, h to the power 4. In this next question, we need to subtract some fractions that have algebraic terms. To subtract fractions, you need a common denominator. So we're going to start by finding the common denominator, which will be the lowest common multiple of the 2 denominators we can see. To do this, we're going to find the lowest common multiple of 6 and 8 first. The lowest common multiple of 6 and 8 is 24. So we want to put 24 on the denominators. Then we're going to look at each letter and consider the lowest common multiple of those. The lowest common multiple of x to the 3 and x is x to the power 3. It will always be the highest power of x that you have. So x to the power 3, and the same idea applies to the y's. We've got y and y squared, and the highest power is y squared. So the lowest common multiple and the denominators need to be 24 x to the power 3, y to the power 2. Now we need to work out the numerators. To do this, we need to consider what we would have multiplied 6 x to the power 3 y by to get 24 x to the power 3 y squared. Well, to get from the 6 to the 24, I would have multiplied by 4. Now the x to the power 3 already matches, so that's good. And to get from the y to the y squared, I would need to have multiplied by y once again. So I need to multiply my numerator by 4y. 7 lots of 4y is 28y. We'll now do the same thing for the second fraction. So how do we get from 8xy squared to 24x cubed y squared? Well, to get from 8 to 24, we multiply by 3. To get from x to the power 3, we need 2 more x's, so x squared. And y squared already matches, so that's done. So on the numerator, we need to do 1 times by 3x squared, which is 3x squared. Now that we have the same denominators, we can combine them to one fraction. So on the top, we'll have 28y minus 3x squared, and on the bottom, 24x to the power 3, y to the power 2. In this question, we have 2 students from different year groups that are going to be selected to play a chess match, and we need to show that there are more than 500 ways of selecting these students. Well, if they're in different year groups, we've got to consider the different possibilities. We could have one of the students being in year 7 and one of them being in year 8. There are 11 students in year 7 to pick from and 15 in year 8. So the number of ways of picking a year 7 and a year 8 is 11 times 15, or 165. Now another possibility is that one of them's in year 8 and one of them's in year 9. There are 15 students in year 8 and 13 students in year 9, so we could do 15 times 13, which is 195. The final possibility is that one of them's in year 7 and one of them's in year 9. There are 11 in year 7 and 13 in year 9, so 11 times 13, or 143. If you add all of these together, you'll get the total number of ways, which is 503, which is greater than 500. In this question, we have similar solids x and y. Since they're similar, we can consider the length, area, and volume scale factors. We can work out the length scale factor because we've been given the heights of both of them. They're 6 and 7.2. So we just need to work out what we multiply 6 by to get to 7.2. Using your calculator, 7.2 divided by 6 is 1.2. Since the height is a length, we can say the length scale factor is 1.2. We can now get the area scale factor by squaring the length one. So the area scale factor is 1.2 squared. And the volume scale factor by cubing the length one. So the volume scale factor is 1.2 cubed. So to get the missing surface area for y, we can just multiply the surface area of x by the scale factor, which is 1.2 squared. So 240 times 1.2 squared, which is 345.6. For the volume scale factor though, we're going in the other direction. So rather than multiplying, we're going to divide. The volume scale factor is 1.2 cubed, so we do 432 divide by 1.2 cubed, which is 250. For the first part of this question, we need to complete a table. To work out the values for the table, it's much easier to write all of these numbers in order. So I'm going to cross off each one and write it down in the correct order. So the lowest one is 23, then it goes 24, 31, 37, 39, 44, 46, 47, 50, 52, 55, 55 again, 60, 66, and 68. Now the lowest time and the highest time are really easy. The lowest one's 23 and the highest one's 68. We're next going to look at the median. To do the median, we need to know how many numbers are in our list, and there are 15. So we can do 15 plus 1, and then divide this by 2. 15 plus 1 is 16, and half of this is 8. This tells us the number in the 8th position is the median. So if you count through to the 8th number, you'll find it's 47. So the median is 47. Now for the lower quartile, we use the same formula, but instead of dividing by 2, we divide by 4. 15 plus 1 is 16, and divide that by 4 is 4. So the lower quartile is in the 4th position. So if you count through in order, the 4th number is 37. So that's the lower quartile. You can find the upper quartile in two ways. You could multiply the 4th position by 3 to get the 12th position, which will be 55, or you could also think of this as counting 4 numbers back from the greatest number. So if you go 4 back from the 68, you end up at 55. So the upper quartile is 55. For the second part of the question, we need to draw a box plot. To do this, we start by drawing a vertical line for each of these numbers. So one at 23, one at 37, one at 47, one at 55, and one at 68. We then connect together the middle three to form a box like this, and then we draw in these lines from the least value to the lower quartile, and one from the upper quartile to the greatest value. And this is your completed box plot. In the final part of the question, we need to write down the interquartile range. This is the upper quartile, which is 55, subtract the lower quartile, which is 37. 55 take 37 is 18, so the answer is 18. This is another topic that I have a video dedicated to. There's a link in this video's description. In this question, we're looking to find the volume of this triangular prism. In order to do this, we're going to need to find this length here, which goes from C to the centre of the baseline AB. In order to find that line, we're also going to need to find this line here first, which connects together the centre of the line AB to the point E. If we look closely at this triangle here, it's actually a right-angled triangle on the base of the prism, so it looks like this. The height of it is BE, which is 14.4, and the base will be half of AB, so half of 8.4, which is 4.2. Since we know two sides of this right-angled triangle, we can find the remaining side using Pythagoras. So let's label the remaining side, the hypotenuse, as C. We can then write down that C squared is equal to the sum of the squares of the other two sides, so C squared equals 4.2 squared plus 14.4 squared. If you work out 4.2 squared plus 14.4 squared, you get 225. And then if you square root both sides, you find that C is equal to the square root of 225, which is 15. So C will be 15. Let's add that value of 15 onto the diagram. Now if we look at this triangle here, it's also a right-angled triangle. It looks like this. The hypotenuse is 17 and the base is 15. Since we know two of the sides, we can use Pythagoras a second time to work out this side, which we'll call A. Since we're finding one of the shorter sides, we write A squared is equal to 17 squared subtract 15 squared. If you do this in your calculator, you'll find that a squared is equal to 64. So if we square root both sides, a will be the square root of 64, which is 8. We can also now add this 8 onto our diagram. We're now able to work out the volume because we have all the information we need. To find the volume of a prism, you do the area of its cross-section times by its length. The cross-section of this one is this triangle. So we do the area of that triangle, which will be 1/2, times the base, which is 8.4, times the perpendicular height, which is what we worked out, at 8. Using your calculator, you get 33.6. All we need to do now is times it by how long the prism is, which is this length here at 14.4. So 33.6 times 14.4 gives you the answer 483.84. And that's the answer to the question. In the first part of this question, we need to estimate the acceleration for when t equals 10. Since we're working with a speed-time graph, we can find the acceleration by finding the gradient at this point. This graph is curved, so to find the gradient, we're going to need to draw a tangent at the time when t equals 10. So if we draw a tangent where t equals 10, it would look something like this. We can now find the gradient by drawing a gradient triangle that looks like this. We'll need to work out the change in y and the change in x. We'll do the change in x first. So looking horizontally here, we start at 0 and we go all the way up to 16, so that's a change of 16. Looking vertically, we go from 24 all the way to 45. 45 take away 24 is 21, so it's a change of 21. We can now work out the gradient by doing the change in y, which is 21, over the change in x, which is 16. If you use your calculator, this comes out at about 1.3. For this question, it depends somewhat on how you drew your tangent, but as long as it's somewhere near to 1.3, you'll probably be okay. In the second part of the question, we need to find an estimate for the distance travelled in the first 20 seconds. For a speed time graph, the distance travelled is the area underneath the curve, so we need to find the area underneath the curve in the first 20 seconds, or at least an estimate of it. We've been told to use 4 strips of equal width. If you divide 20 by 4, you get 5. This means we're going to draw a vertical line every 5 seconds up to 20 seconds. We then connect together the tops of each of these lines like this, and this is the area that we're going to find. You can see it's made up of 1 triangle and 3 trapeziums. Before I do this, I'm just going to write down the lengths of all of those vertical lines. The one at 5 seconds is 25, the one at 10 seconds is 37, the one at 15 is 41, and the one at 20 is 42. So let's start with the area of the triangle. To do the area of a triangle, you do 1/2, multiplied by the base, which goes from 0 to 5, so that's 5, multiplied by the height, which is 25. And if you do this on your calculator, you get 62.5. Then if we move on to the next strip, which is the trapezium. To do the area of a trapezium, we do 1/2, multiplied by the sum of the parallel sides, which is the 25 and the 37, and then we multiply this by the height. But rather confusingly, this trapezium's on its side, so the height is actually the width, which goes from 5 to 10, which is 5. Typing this into your calculator will give you 155. Now we move on to the third strip, which is the second trapezium. We'll do 1/2, multiplied by the sum of the parallel sides, so this time the sides are 37 and 41, and then multiplied by the height again, which is that width again, which is also 5. In your calculator, this will give you 195. Then we move on to the final strip, which is also a trapezium, so 1/2 times the sum of the parallel sides, which are 41 and 42 this time, and then times by the height, which is the width, which is 5. And on your calculator, this gives you 207.5. So if we add up all of this, we get the total area, which is 620, and we said earlier the area is the distance travelled, so 620. If you find any of this question difficult, I have a video dedicated to speed time graphs. I'll put a link in this video's description. In this question, we've been given a graph y equals f of x, and in the first part, we've been asked to draw the graph of y equals f of x minus 1 plus 2. This topic is transformations of graphs. Whenever we do something to the x inside the function, that's going to affect the horizontal direction. Now, you would think a -1 would move the graph to the left, but it actually works in the opposite way. So it'll move the graph to the right. So this graph needs to move 1 to the right. Whenever you do something to the entire function, to this plus 2 on the outside, that affects the y direction, but it does more what you expect. A plus 2 will move the graph up 2. So this graph needs to be drawn and then moved 1 to the right and 2 up. So you just need to draw a graph that goes here. You may want to use tracing paper to help you with this question. In the second part of this question, we're told about the point A, which has coordinates 1, -3. So that's this point here. Then we're told the graph is transformed to the equation of y equals f of -x, and we need to write down the coordinates of B, which is where this point will map to. The graph of y equals f of -x is a reflection of our current graph in the y-axis. So any points to the right of the y-axis will move to the left of the y-axis. Our point is only 1 square away, so I'll move 1 square past the axis and go here. So the new coordinates are -1, -3, and that's the answer to the question. In this question, Dylan calculates the density of the cylinder to be 2.9, and we need to show that he is incorrect. To calculate density, we use the formula density equals mass divided by volume. You can see we've got the mass of the cylinder in the question. It's 8,300 kilograms, but it's given to two significant figures. This means it could be anywhere between 8,250 and 8,350 kilograms. Now we don't have the volume, but we are given some information about the height and radius. They're 2.3 and 0.7, but given to one decimal place. This means the height could be anything in between 2.25 and 2.35, and the radius could be anything in between 0.65 and 0.75. In this question, you need to spot that Dylan's density was given in grams per centimetre cubed, but our mass is in kilograms and not grams, and our lengths are in meters, not centimetres, so we're going to need to convert them first. To turn the kilograms into grams, we multiply them by 1,000. So the mass is actually in between 8,250,000 and 8,350,000 grams. To turn the height and radius from meters to centimeters, we multiply by 100. So the height is actually in between 225 and 235, and the radius is in between 65 and 75 centimeters. Now we said a moment ago that density was mass divided by volume, and we have the mass but we don't have the volume, so we want to calculate the volume of this cylinder. The volume is worked out using the formula pi r squared h. Now since we have a maximum and minimum possible height and radius, we'll have a maximum and minimum possible volume. Let's start with the lowest possible volume. This would be pi, multiplied by the lowest radius squared, so 65 squared, multiplied by the lowest height, so 225. If you do 65 squared times 225, you end up with 950,625. So it's 950,625 pi. You could type this into your calculator including the pi if you wanted, you'll just get a much larger, more difficult number to work with. Next we'll do the largest possible volume. So it's pi times the largest radius squared, so 75 squared, multiplied by the largest height, so 235. If you did 75 squared times 235, you get 1321875. So it's 1321875 pi centimeters cubed. So we've now got the minimum and maximum values for the volume. So the volume must be somewhere in between these two values. We no longer need the information about the height and radius, but we do need the mass for the density formula. To work out the maximum possible density, we do the maximum mass divided by the minimum volume. This is because when you divide by a smaller number, you get a greater answer. So we want to use the minimum volume possible. So the maximum mass was 8,350,000 grams, divided by the smallest possible volume, which was 950,625 pi. If you type this into your calculator, you get this as the answer here. So we've just demonstrated that the maximum possible density is 2.7959 and so on grams per centimetre cubed. This means that Dylan's answer of 2.9 isn't possible, because it's greater than the maximum possible density. So we could say 2.79 and so on is the maximum density. Dylan is wrong, as 2.9 is greater than 2.79. In this question, we need to work out the area of triangle ABC. We're going to need to do some work with angles first. If we draw in these two lines here, we create an angle at the circumference. There's a circle theorem that says the angle at the circumference is half the angle at the centre. The angle at the centre is 130, so if we half that, we get 65, which means this angle must be 65 degrees. It's then possible to work out this angle here. This shaded shape is a cyclic quadrilateral. The opposite angles in a cyclic quadrilateral add to make 180, so we can take away 65 from 180 to find this angle, which is 115. Now if we turn our attention to the triangle we're trying to find the area of, triangle ABC. We already know two of the angles in this triangle, so we can work out the remaining one by subtracting these two from 180. So 115 plus 20 is 135, and if we take this from 180, we find the remaining angle is 45 degrees. Now from this point, there are a few different routes you can actually go. We need to find one of the remaining sides of the triangle. I'm going to find this side here, which I've labelled A. I'm going to do this using the sine rule, so the angle opposite this would be capital A. I can then label the 13 centimeters as B, and the angle opposite that one, which was the 45, as capital B. The sine rule says that A over sine A is B over sine B. If I just substitute my numbers in from the question, it would be A, which I don't know, over sine of A, which is sine of 115, is equal to B, which is 13, over the sine of B, which is sine of 45. I can now find A by multiplying both sides by sine of 115. On the left-hand side, this will cancel the sine 115, so I'll just have A, but on the right-hand side, 13 lots of sine 115 over sine 45. If you found this part tricky, I have a whole video dedicated to the sine rule. Of course, that will be linked in this video's description. You can then just type this into your calculator and you'll find the value of A is 16.6622 and so on. So we can now add this onto our diagram. You can see in the question we've labelled two of the angles in the question as A and B. The remaining angle is a capital C. We can now use the formula area equals 1/2 times A times B times the sine of capital C. This will work out the area of the triangle. So it's 1/2 times A, which was the number we found, 16.66 and so on, times B, which is 13, times the sine of C, which is the sine of 20. If you type all of this into your calculator, making sure you use the full number for the 16.66 and so on, you'll get this number here. The question says to round your answer to 2 decimal places, so it's 37.04. In this question we have this sequence here, which we're told is a quadratic sequence. For any quadratic sequence, the second difference is always the same. So let's try and work out what the second difference is for this sequence. Let's do the first differences first of all. Now, since k is not a number here, it might seem like we can't work out the first differences, but we can, it will just be in terms of k. So to get the first difference, we would normally subtract the first two terms. The second term is k, and the first term is 387, so we'd do k, whatever that was, take away 387. For the next one of these differences, we'd do 892 take away k, so it's just 892, subtract k. For the next one, we actually have the numbers, so we can do 1167, subtract 892, which gives you 275. Now we're ready to work out the second difference, which is the difference of these differences. So to work out the one of these on the left, we would do 892 subtract k, and then subtract from this, k take away 387. Now you need to be careful and make sure you use brackets here. We've got 892 subtract k, and we don't actually really need the brackets for that part, but we need to be careful with our signs on the second part. First of all, we're going to subtract k, so subtract k, but then we're going to subtract negative 387, which actually means we need to add 387, and that's why you need to be careful with your signs and use of brackets here. We can now simplify this. If we add 892 and 387, you get 1279, and then we've got minus k, which is minus 2k. So this difference is 1279 subtract 2k. We can now do the same process for the next one. So it's 275 subtract 892 subtract k. So we've got 275 subtract 892, but then we're going to subtract a negative k, which means we add k. So this equals k, and then 275 take away 892 is negative 617. So it's k subtract 617. Now I said earlier that for any quadratic sequence, the second differences are always equal. So these two expressions here that are in blue must be the same. 1279 minus 2k must be the same as k minus 617. So we can set them equal to each other. This now just gives us an equation to solve to find k. Let's begin by adding 2k to both sides. On the left-hand side, we'll just be left with 1279, but on the right-hand side, if we add 2k, we get 3k minus 617. Then if we add 617 to both sides, on the left we need to do 1279 plus 617, which is 1896, and on the right the 617 will cancel, so it's just 3k. Then we can divide both sides by 3, which gives you 632 on the left, and 3k divided by 3 is k on the right. So we find that k is equal to 632. In this question we've got an inequality, On the left-hand side, it says f(g) of x. To work out f(g) of x, I need to take the f function, but use the entire g function as the input. I like to do this in the following way. f(g) of x equals the f function, but I'm going to replace the x with a bracket. So instead of x squared minus 9, it's bracket squared minus 9. Then inside that bracket, I put the whole g function, which is x minus 3. X minus 3 all squared just means x minus 3 times by itself. And then we've also got this subtract 9 on the end. Let's expand this bracket. X times x is x squared. X times negative 3, negative 3x. Negative 3 times x is also negative 3x, and negative 3 times negative 3 is positive 9. And then we've also got this subtract 9 at the end. So if we simplify, we end up with x squared minus 3x minus another 3x is minus 6x, and 9 take away 9 is actually 0. So this is what it equals, x squared minus 6x. Now if we look at the right-hand side of the inequality, we've got g of x, which we know because that's given in the question, but then we have the inverse function for h. So we're going to need to work out the inverse function of h. So if we take h of x, but replace the h of x with a y, we've got y equals x minus 8 over 3. To find an inverse function, we're going to switch all of the y's to x's and all of the x's to y's. So the y on the left-hand side will become an x, and the x on the right-hand side becomes a y. Now we want to make y the subject. We can do this by multiplying both sides by 3. On the left, x times 3 is 3x, and on the right, a 3 will cancel, so it's just y minus 8. Then we can add 8 to both sides. On the left, 3x plus 8 is 3x plus 8, but on the right, the 8's will cancel, so it's just y. We can then replace the y with inverse h of x. So we've managed to work out the inverse function, it's 3x plus 8. Now if we write this back up at the top, we're ready to turn our attention back to that inequality. We now know each of the parts of this, so we can write it out. f(g) of x on the left-hand side was x squared minus 6x. Then it's less than, then it's g of x, which is given in the question, x minus 3, multiplied by the inverse function for h, so 3x plus 8. And this is all divided by 10. So we've just got to solve this inequality. Let's begin by multiplying both sides by 10. On the left-hand side, if we multiply by 10, we get 10x squared minus 60x. On the right-hand side, the 10 will cancel, so it's just less than x minus 3, 3x plus 8. Let's leave the left-hand side as it is and expand the right-hand side. X times 3x is 3x squared. Negative 3 times 3x is negative 9x. X times 8 is plus 8x, and negative 3 times positive 8 is negative 24. We can simplify the negative 9x plus 8x to give us negative 1x. So what we have here is a quadratic inequality. To solve this, we want all of the terms on one side. Since there's more x squareds on the left-hand side, I'm going to get all of the terms on the left-hand side, so the right-hand side is 0. That means all of these terms here need to be gone. So we know the right-hand side is going to be 0, we just need to think about what we did to get 0, and do this to the left-hand side as well. So to deal with the 3x squared, we would have subtracted 3x squared. So we need to do 10x squared subtract 3x squared, which is 7x squared. To deal with this negative x, we would have added x. So we need to add x to negative 60x, which is negative 59x. And then we've also got this negative 24, so we must have added 24, so we just need to add 24. At this point, you could either use the quadratic formula, or you could factorize. This one does actually factorize. To get 7x squared, we only have one option, which is 7x and 1x. To get a positive 24, we must multiply two positive numbers or two negative numbers. Since the 59 is negative, we actually know it must be two negative numbers. You then just need to think of your factors of 24, and with a bit of inspection, you should be able to arrive at 7x minus 3, x minus 8. We can now take this inequality and consider its critical values. To do this, we imagine that each of the brackets is equal to 0 and solve it. So 7x minus 3 equals 0 and x minus 8 equals 0. To solve the one on the left, we would add 3 to both sides, which is 7x equals 3, and then divide both sides by 7, so x will be 3 over 7. On the right-hand side, we can add 8 to both sides, so x will equal 8. This gives us the two critical values. What this means is if we drew a graph of this, it will end up with a nice quadratic shape, but it will cross the x-axis at these two values, so 3/7 and 8. In our inequality, we have a less than sign, so we're looking for when this graph is less than 0, which means we are underneath the x-axis. So it's this portion of the graph that we're interested in. We want to find the x values that give this portion of the graph. And those x values are to the right of 3/7 and to the left of 8. So they're the values in between 3/7 and 8. So we could write down that x is in between 3/7 and 8. And that's your solution to the question. Thank you for watching this video. I hope you found it useful. Here are some rough grade boundaries that you might want to use to get an idea, but remember we don't know the real grade boundaries until after the papers have been done. Check out the video that I think you should watch next and subscribe so you don't miss out on my future videos.